The visualizer demonstrates Wigner rotation and its continuous physical manifestation as Precession, both of which arise when a moving reference frame experiences successive, non-collinear Lorentz boosts. When a frame undergoes an initial velocity boost along one coordinate axis followed by a secondary boost along a perpendicular axis, the non-commutative nature of relativistic velocity addition ensures that the final composite transformation consists of a diagonal drift combined with an intrinsic spatial rotation. In a discrete linear simulation, this causes the coordinate axis aligned with the first boost to warp and tilt dynamically while the perpendicular axis remains parallel to the laboratory grid lines. When extended to continuous acceleration, such as an electron in a uniform circular orbit around an atomic nucleus, this infinite sequence of infinitesimal, non-collinear boosts manifests as a steady angular precession of the particle's intrinsic spin vector. This purely kinematic frame twisting effectively cuts the expected spin-orbit interaction energy in half, providing the necessary relativistic correction to align theoretical quantum mechanical predictions with experimentally observed atomic fine structure energy levels.